Hello everybody, this is Mr. Longo, and in this video we are going to cover rational expressions and their domain, and simplifying them by factoring and seeing what we can pretty much, let's say, reduce. Okay, so we know that, silly little example here, but let's just take 6 divided by 8. If we wanted to, we can change that to 2 times 3 divided by 2 times 4, and our 2's cancel and we would be left with 3/4. It's known as reducing, but what we're doing is we're pretty much factoring out a common term out of both the numerator and denominator, okay? So, like I said, silly little example, but that's how we're going to be thinking about these next 4 questions. So, the first thing that you have to do when simplifying a rational expression is to factor the numerator and the denominator if it can be factored. So if we were to look at number 1, this is just an example of unfoiling, as some people call it, or just factoring, splitting the middle term. If that's however you have learned how to factor this, just do it. What multiplies to 4 and adds to 5 would be 4 and 1. So our numerator would just be factored to x plus 4 times x plus 1. And that is over. Now all we're going to do is factor our denominator. X squared minus 16 is an example of the difference of 2 squares, which would simplify to x plus 4 times x minus 4. And what we're going to do now is look for the exact same terms. Now, when I say that, I mean don't cancel out an x and an x if they're in parentheses or in a group. It has to be the exact same term. So we have x minus 4s that can cancel from both of them. And now there's nothing else that can be done. So our simplified expression would be x plus 1 over x minus 4. And that's it. We are done. So now we need to talk about what the domain is, because this is going to be important when it comes to graphing. So this video is kind of like your preview to graphing rational functions. So once we have a simplified expression, to find your domain, you need to think about what values are not allowed. Now, to do that, you have to look at a couple of things. The first thing you should look at is your denominator. We know that you cannot divide by 0. So to find one of your domain restrictions would be to set your denominator equal to 0. And that's the value that x is not allowed to be. So if we were to take x minus 4, set it equal to 0, we would get x is equal to 4. Now that is going to be one of our domain restrictions. The other thing is anything that cancels. Whenever you have two terms that cancel, in terms of the function graphically, it creates what is known as a hole. And if you were to type the original example into your graphing calculator, it would give you a funky hyperbola. But what would happen is if you were to look at the values, you would find out that -4 is also not able to exist because they cancel one another out. So another thing you would do is take your hole, or what cancels, and you set that equal to 0 as well, and solve again, and we have x is equal to a -4. Okay, so these guys right here, after you simplify, these are known as your domain restrictions, okay? So that's actually going to represent what it is not allowed to be. Okay, so this is what it cannot be. So how do we do that? How do we write this as a domain? Well, it's just a simple notation that we write like this. So we have our domain, and we're going to have a set. And the way we write this is x, and then we list what x is not allowed to be. So x is not allowed to equal -4 or 4. Okay? And that's it. So again, it's a notation that basically says that x can exist except for when x is negative 4 and 4. That's pretty much what that says. Okay, so your domain, x can be any number except negative 4 and 4. Okay, so that's domain. It's listing what values you are not allowed to have. So why don't you just pause the video for a second and try to factor and simplify number 2 and try to state any holes or domain that may exist. Okay, so give it a shot. All right, let's see how you did. So the first thing you should have done is factored out a negative 1 in your numerator, and then we could rearrange that to x squared minus 25 over x minus 5. And then we're going to factor our numerator again because that's the difference of two squares. So if we were to continue, that would give us a negative x plus 5 and an x minus 5 all over x minus 5. Now notice I wrapped the denominator in parentheses. Those go together. You can't separate those. So if it helps you, keep them in parentheses. We can see that our x minus 5's cancel. Remember, that will create our whole. And our final answer is negative x plus 5. Or you could write negative x minus 5 if you want to, but that's simplified right there. Notice there's no more denominator. If it makes you feel warm and fuzzy, you can write over 1, but there's absolutely no need to. So you can just leave it as negative quantity x plus 5. So there's nothing to set equal to 0 in our denominator. So we do not have any denominator restrictions here. The only thing we have is a whole that canceled. So if we were to set x minus 5 equal to 0, we would get x is equal to 5, which is our domain restriction. And then we would just write our answer that our domain can be any x value except x is not allowed to equal 5 because that would create a hole in that function. Okay? So that is what simplifying and stating domain restrictions for rational expressions are. So we've looked at a lot of things before with domain. We've looked at radicals and we've looked at denominators, and now we can talk about rational functions and when something cancels. Okay? So we have two more examples here, and the only difference is these are just a little bit more challenging in terms of factoring. The steps are still the same. So what you need to do is you need to factor the numerator and denominator, see if anything cancels, set your denominator equal to 0, and whatever you cancel that created a hole equal to 0 to find your domain restrictions, and then just state your domain. So again, two more examples. The only difference is they're just a little bit more challenging to simplify, but all the steps are the same. So I would like you to pause this video and give them a shot on your own. And then when you're ready, click play and I'll walk you through them. Okay, so for number 3, we can see that this is an easy expression that we could have grouped. So if we would have factored out our greatest common factor of the first set, we would have x squared, leaving us with x minus 2. And we would factor out a negative 9 for the second one, leaving us with an x minus 2. So that would give us x squared minus 9 times x minus 2. But x squared minus 9 is the difference of two squares. So if we were to simplify that completely, we would have a numerator of x plus 3, x minus 3, and x minus 2. And now we're going to go factor the denominator. So the first thing we would want to do with our denominator is we can see that there is a greatest common factor. So we could factor out a 2x from this entire thing. So I'm going to do my work for the denominator separately over here. So that would give me a 2x, leaving me with an x cubed. I'm sorry, an x to the 4th minus 7x squared plus 12. And then we are going to simplify the denominator here. This can be factored using a quadratic form, but remember we're starting at the fourth, so we're still saying what multiplies to 12 but adds to a -7. That's going to give us x squared minus 4 and x squared minus 3. And we can see that we have another difference of 2 squares. So we're going to do that one last step, but I'm going to write that down here. Our denominator for this example is going to be 2x times x plus 2 times x minus 2 and x squared minus 3. Okay, so again, like I said, nothing really different has happened. All I have done is factor. It was just a little bit more work than the first couple examples. So now what are we going to do? We're going to see what we can cancel anything. We can cancel x minus 2's. So that creates our whole. And I'm just going to set that equal to 0 now, and x equals 2 is going to be one of my restrictions. Now the other thing I have to do is remember we need to set anything that's in the denominator equal to 0. Now that's easy enough for us to do in our heads. 2x is equal to 0, so x is equal to 0. X plus 2 is equal to 0, so x is equal to a -2. But this one right here, remember, this is x squared minus 3 equals 0. So I want you to make sure that you remember when you square root this to get x by itself, we have x is equal to plus or minus the square root of 3. So I know what you might be thinking, can we use that in our domain? And the answer is yes, that's because the square root is a real number. So when we're stating domain, we're only going to state real numbers. So our final answer would be our domain is x can be anything except x is not allowed to equal a -2. It's not allowed to equal 0. It's not allowed to equal 2 from our whole. And it's not allowed to equal plus or minus the square root of 3, because that right there, again, is a real number that would cause a problem in our denominator. Okay, so again, that example, that's not meant to be difficult, just a little bit more challenging in terms of factoring. All right, I'm going to walk you through the last example here. As you can see, this is not really in the correct order that we would like. Remember, you should always rearrange things in descending order, also known as standard form. And to do that, all we would do is make this negative 3x to the fourth plus 24x, and now that's going to be easier for us to work with. Okay, so starting with the numerator again, the first thing I would do is factor out a -3x, and that's going to leave me with x cubed minus 8. Now, you should already notice right here that that's going to be the difference of cubes. So if I were to factor that using the difference of cubes, I'm going to skip all the way down here to my numerator for this. We would have a -3x, and the difference of 2 cubes would say that our first term is x minus 2, and our second term is x squared plus 2x plus 4. Okay, so we've already taken care of the numerator. Now we're going to go play with the denominator. So our denominator here is, we're going to factor out a -x, leaving us with x squared plus 2x plus 4. And you should notice that we can't think of anything that multiplies to 4 but adds to 2. So that's actually done. We can't factor that anymore. So our denominator is going to be a -x times x squared plus 2x plus 4. And we are ready to see if there's anything that can cancel. So we can cancel, in this situation, our x squared plus 2x plus 4. We can cancel our x's, and we can cancel our negatives. So what is left after all of that is simply 3 times x minus 2. Okay? So as you can see, again, we do not have a denominator, so we do not have to worry about any of our denominators. You cannot set a negative symbol equal to 0. That just sounds ridiculous. So the negative symbol just kind of goes away. But we do have two expressions that canceled that could have a value for x. And one of them is x, and if we were to just set x equal to 0, we're going to get x equals 0. But the other one is the x squared plus 2x plus 4. Now, I'm going to spare you the time of using the quadratic formula or completing the square right now and tell you that if you were to solve that, you would also get x is equal to negative 1 plus or minus I root 3. Now, the reason why I'm telling you that is because we still have to write the domain, and we have to write the domain in terms of real numbers. We can't say that x is not allowed to equal some imaginary number. So our domain here, after all that work, is x can be anything except x is not allowed to equal 0. Okay, we do not list imaginary numbers in our list of domain restrictions. Okay, so again, you can see that there is quite a bit of work involved with these problems from time to time, but it's always the same thing. Factor, simplify, see what you can cancel, set your denominator equal to 0 after you're done simplifying, and anything that cancels that created a whole equal to 0, and then you can go write your domain. Okay, that's it for this video. This is Longo and I'm out. See you, bye.